Hello, my name is Sarah Stagg, and I will be nominating Sucralose as Molecule of the Year for the Hero Division. Now, sucralose has a chemical formula of C12H19Cl3O8. Its molecular weight is 397.6 grams per mole and has enantiomers as well. This molecule exhibits no planes of symmetry whatsoever. On the right-hand side here, we have a picture of the molecule. Moving on to the physical characteristics, sucralose has a melting point of 130 degrees Celsius and a boiling point of 669.1 degrees Celsius. It's freely soluble in water and surprisingly is also freely soluble in methanol and ethanol. This molecule appears as a white crystalline powder that's sweet to the taste. Over on the left is what pure sucralose looks like. Sucralose is a solid crystalline substance at room temperature, about 20 degrees Celsius, and it is completely safe for human consumption. There have been no reported detrimental effects on health traced back to sucralose. Even though it's non-toxic for humans and while it is not usually flammable, if there is a heavy concentration of sucralose dust in an enclosed space, it can create conditions that contribute to dust explosions. Regarding its molecular shape, it's a complex ring-like structure containing two heterocyclic rings, one 5-membered and one 6-membered. In both rings, one carbon atom is replaced with a chlorine atom. It has 9 chirality centers and is a non-planar tetrahedral arrangement centered around many of the carbon atoms. Sucralose has an identical molecular structure to sucrose, except 3 of the hydroxyl groups are replaced with chlorine atoms. There's a reason why sucralose and sucrose look chemically similar, which we'll get to later. Here are 2 pictures of the molecular structures of sucralose and sucrose, respectively. Notice the similarities between the two. Sucralose, which is a disaccharide, is used in everyday life. It's used as a low-calorie alternative to sugar. Because of its status as a low-calorie sweetener, it doesn't affect insulin levels and promotes lower calorie intake when used instead of table sugar, also known as sucrose. Sucralose is also safe for cooking. These are some of the benefits of using sucralose. There are no drawbacks too. Similar molecules are aspartame and saccharin. Sucralose is extremely easy to find. It can be found in most grocery stores in pure form or found in some sugar-free products. It was originally discovered in 1976 during a sweetener joint research project investigating the relationship between structure and taste after altering a sugar molecule. They found a way to intensify the sweetness and make it non-caloric by modifying the structure of sugar. This is the only way to create sucralose, and it's how it's still made today. My reasoning for nominating sucralose for Molecule of the Year is because of its many health benefits and because it does not cause any harm whatsoever. Diabetics do not have to worry about consuming sucralose because it has no effect on their blood sugar or insulin levels. That means that they can consume their favorite sweet snacks and drinks without worry. It's also environmentally friendly since it doesn't accumulate in the environment and is non-toxic to all plant, animal, and aquatic life. Lastly, it's a great way to make a small change in diet when looking to lower calorie intake and promote weight loss. That's why I think sucralose should be awarded Molecule of the Year.